afterwards. So please take it away, you two.
Okay, so maybe I should start with quick background. One headache is how do we get a good ground truth neural system that we can then try to scan and check that our scanning method is actually producing something that fits with ground truth. Real biology is tricky because we actually don't know what the ground truth is. So let's make something up. And that is what the neural pretty printer is. Basically, we take an artificial neural network, which might be something totally simple, like an XOR two-layer network or GPT-2. We convert that into a Hodgkin-Huxley compartment model, which has some biological realism, convert that into computer graphics of neurons in free space with synapses, etc., and then convert that into a noisy picture, a bit like what you would get out of a scanner. Then it's off to the races. Now the task is, given this stack of images, can you now reconstruct things?
And then you'd also be able to simulate whatever type of live data you want as well. So you could get something as blurry as an fMRI or something as accurate as some sort of magical every single compartment voltage signal or anything in between, like a realistic voltage dye, calcium imaging, etc. You could also, it's in some way, the function of the original neural network, right? It's a way to transform that function to something that's has more physicality to it. And so you could propose all sorts of insidious, obnoxious things that you think biology might do, though it'd be hard to upload. For example, you could say, I think gap junctions are important. So you could command the pretty printer to integrate gap junctions into its model and sort of sync some of the functionality of that network into those gap junctions being necessary when it runs the simulation. And then you could have an analogous labeling of like antibodies to label said gap junctions. And eventually you might have such an annoying system that you think it's probably harder than whatever biology is doing.
And if you can scan that, okay, then you're golden. But another interesting thing here is that you can test out various methods also of generation. The full system eventually might very well be very much like the systems used at CERN for predicting what will things look like if we build that particle collider. Before we built the Large Hadron Collider, they had software generating simulated particle collisions and then thinking about what happens when we put the detectors in different places. And they are modular. I've been going through one module about black hole decays, for example, with some interest. And you can actually, it's fairly common that people in physics generate these simulated things and say, you should be looking for these patterns. And this happens, of course, in other parts of science too, including parts of neuroscience. So this would just be adding it to the whole brain emulation pipeline.
One thing that is bizarre is it's not currently possible, as we understand it, that there's any software that will generate a non-overlapping neural network. So while you can simulate some neural networks, if you try to give them a real physicality where it's like the processes are 80 microns wide, they do this thing where they act like video game characters without collision and they just physically go through each other. And it takes a primitive but not like especially complicated physics simulation to not have them overlap each other.
So implementing this looks like it's not entirely trivial. It's not something that we could do in an afternoon, but it also looks like the kind of thing that you can actually get graduate students to do over a long span of time or engineers that you pay to actually do it much faster.
I'm thinking 6 months to engineers, like less than $1 million, and doesn't need a supercomputer, but needs like some good hardware. And you could do this to ChatGPT too.
So the interesting thing here is that when you start out, of course, with the test case, the simplest possible networks. And here we had an interesting disagreement in the group about should we start out with simple network and demonstrating our scanning methods on them, or should we start out with some complicated network like GPT-2? And you can, once you have a pretty printer, you can kind of have a competing approaches compete with each other.
Yeah, so that's the idea.
Yep, that's basically the Neural Pretty Printer project. Any questions?
I'll ask this question for Alison, actually, because in these projects it says participants interested in exploring the project, but for example, the Pretty Printer and the thing we talked about actually came out of the same group. Basically, everybody was interested, so should we just add our names on both projects?
Yeah. You absolutely should. The more the merrier. You can always afterwards take your name out, but if you generally want to be emailed about this project or be considered for funding for this project, whatever you may have.
This is not just for people in group 1.
Yeah. So it's peer review. We like it. What do you guys think?
Yeah. Yes. Have it. Oh, you please take questions. Yeah.
Yeah, okay, so I think attention layers are right out because I don't think we know how to implement softmax in a Hodgkin-Huxley realistic way. And also don't really know how to implement ReLU. So I'm wondering, like, do we need to train networks with like sigmoidal nonlinearities in the first place, such that there is a biologically plausible way of rendering them?
I'm kind of fine with that. I guess Rob is less happy with that work.
Because you're excellent that way.
I think I care about it.
Yeah.
I don't think I necessarily even care about it being Hodgkin-Huxley. Like, I would actually be fine with the initial thing of it literally just lighting up, or not lighting up if it's firing, and having physical connections that have some sort of sense to them.
But I would be happy to try to move it as close to biology as possible. So one of the things that if this tool actually became good, useful, the development path would be, of course, to eventually try to use the actual biological data to train on that to make things look as much as biology as possible, because that's going to make it better as a testing unit. But I think it's an interesting issue. How easy is it to translate a simple artificial neural network into Hodgkin-Huxley? And I was hand-waving over that. Sometimes it's easy, sometimes it's not. We might want to give some extra thought to that, how to implement it right.
Temporal synchronization, I think, would be another obstacle.
Yeah, you want to start with a artificial but spiky neural network rather than
Perhaps.
based.
Yes.
That would make it easier.
Yeah. Originally, I was imagining you'd have compartments with the initial data pre-printed. It would be simpler, but still physical. So the main thing is you want microscopy data out of it that's legit, and you simulate cutting out artifacts for it. And you see if it works by masking parts of it. This was to test the other pipeline.
We had a question from Barry and Kenneth.
So I just wanted to ask about, you're creating this 3D model and then scanning it and trying to replicate the original function. Is there a danger there of overfitting? So if there's some functionality and you're creating a model to reproduce that functionality, you're not capturing the mechanisms in that network, you're just capturing the output. And so you might reproduce the same output for whatever you're training it on, but then things that you're not testing for, so...
You memorize a password, and you don't explicitly test that, and you see if you get the password back out. But also, more generally, you can just have a vast class of inputs and outputs, and you only do a little bit of training on what the activity is. A realistic version of this, it would have as much time as it wants to spend on analyzing the network structure, and it would get like a tiny little sliver of simulated fMRI data to try and like complete that simulation that would not be adequate to get anywhere near to full functionality. So the only way if it does get functionality is because it's attending to the structure that way.
It's also worth noting that the imagery we might imagine actually use procedurally generating glial cells, for example, filling things up. And we might even be even naughtier later on and say the glial cells actually have functional effects of this network. So eventually you want this to be a test suite.
So if it turns out that the glial cells have functional effects, which for instance we don't understand, then I guess this network might sort of fool you into thinking that we've created something which can, given imaging data, accurately decode the structure. But that was only true because the structure represented by the imaging data didn't have significant glial cells.
Yeah, so this just does provide a more in line with allowing you to realize the procedure won't work rather than it will work.
If your method can't scan even the network, you know it works.
Yeah, okay.
Then you know that, okay, this can't possibly work. Cool. And later on we can have red teaming. We had some fun ideas about red teams coming up with devious biological effects putting it in. And now it was the blue team doing scanning, trying to figure out why this our model not working. Oh, the glial cells are doing something naughty here.
It's also a case of making a tool set that you can use throughout various stages of increasing complexity and going towards using actual slices and animals, where the same set of tools that you built to be able to do your in silico first experiment, you can then use to prepare for the next experiment and to have your methodology ready for doing your metrics, finding out whether you've got the same behavior and all of that. And then as you learn that there are things that you left out, and you figure out what it is that you left out, like the glial cells actually have function, then you go back and you update your pre-printing model to be able to put that into.
I was just hoping you could be more specific about a particular metric. Like I know you have different ideas at different scales, but pick one of them and say this would be a success versus a failure.
So two metrics come to mind immediately. One is masking part of the network as if it had been physically destroyed, and having the statics model regenerate that part of the network. And then you can define how well it did that. And the second one would just be a raw functional assay, which is here's what the input output is for GPT-2 at temperature 0. Does the simulation work?
It's worth noticing that there was a spectrum of complexity that we in our group. Rob is kind of on the high end of spectrum. He wants to have a lot of complexity, a very rather full network. While I was going on about the XOR network, kind of just proving that we can get even that network out. And when you think about different measures, like perplexity, which doesn't make much sense for the super small networks, you need at least a mid-sized network. So we can have different metrics here on how well you can succeed.
Another concrete example of a metric is, for example, to test their kernel models. So basically, you create a metric that gives you the probability function for is there going to be a spike at a certain time. So not specific spike, but probability function of spiking. And you make that for the original data, because you can turn the original data into a prediction like that.
Yeah.
And you also make that, of course, for the output of your model. So you're comparing that with the output of the model. So is it within the envelope of prediction?
Okay. Okay.
We're almost at time. I just want to make sure that we also, I know that you glossed over this a little bit, but like roughly the project outline, how much it would cost, and like how you check for completeness.
750K, 6 months, 2 engineers, something like that.
Okay, and then what are the midterm and final exams?
The metrics we just described, like the truest one is either password extraction or just comprehensive input output.
And what would you be doing with if you were about 1K, 2K, or 3K development grant?
So just write up a grant for it.
Yeah.
Good.
Yeah, it's basically getting a good software specification, and that makes sense.
Final question then, how does this fit into a larger whole emulation roadmap 2.0? Any ideas yet on this?
If
And
you're
whether
a-
you fit in the stack?
Yeah, if you're like a $100 million project that has a conception of an uploading pipeline, then you can test that uploading pipeline on this and maybe save yourself about heartache later if it starts failing at it. And maybe force redesign.
And before that big project, you still might want to have this as a tool for demonstrating when you propose a smaller project, but we have actually a way of testing out our methodology. So it's making a tool for making the rest of big pipelines more feasible.
Is there anyone you particularly need, like specific people that would be really useful to contribute to this project?
I actually think Randall knows a lot about the current state of the art and
Even people not in this room, like
Right.
in general, like, who would you need to recruit for this?
this seems like a straightforward software project.
So I definitely want to talk to Dongsong because they've done very similar
Okay.
things in building their detailed, what they call very realistic model of dentate gyros, which is all compartmental and has like up to 1 million neurons in it with all of the details so they can do experiments with putting in an electrode virtually and finding out how it's doing.
Do those compartments
definitely
overlap
want
each other physically or not?
Hmm?
Do those compartments overlap each other magically or not?
No, they're in 3D space, so they don't magically overlap each other.
That's nice.
And
It is. That's the only
same-
one I've ever heard of in all the literature that does that, so good for that.
I would also like to talk more to some of the imagery people actually. How does it look when it gets up to scan for different scanning types? So we can start thinking about the noise artifacts and how do you make basically the filter from the polynomial representation of our perfect neurons to actual plausible neurons.
okay, awesome. Anything else where you're just like, it's gonna fail because of X? Something you want to point out to them, just like, you need to figure this one
Okay,
out.
my biggest worry is the incredible optimism about how easy the project is. And I know that that's probably a good thing to have in the beginning, especially because I didn't even want to get funded, so, since we're all Chatham hospitals, and just say it. But I think that the actuality of how difficult it is to make a really good preprint or something that actually produces something that seems like reality is much, much harder than we're currently thinking.
What would you estimate it to be to do it right?
All right, in a university setting or like
No, in a
super
company
funded-
setting that's dedicated to actually doing it properly instead of wasting all their money.
Yeah, if you have enough groups working in parallel on different parts of the 3D printer and you don't have to worry about money at all, I would say 2 years to get a good 3D printer. Yeah.
2 years with a team of 20 or 25.
Yeah.
What part of it seems so hard? I mean, taking
There's
graph
unsolved
and
problems
things
of like modeling value, for instance.
Modeling what?
Value.
So the minimum viable bonds doesn't do a compartment model at all. It just like literally lights them up or doesn't if they're firing.
Okay, we
Doesn't
were
have
talking
a
about different
geometry
parts of
itself.
it then.
Because you
Because
said
I was
nothing-
thinking about the part where you could make a compartmental model, you can get a fairly good EM, simulated EM from it, you can get a fairly good, like, you put an electrode somewhere in this virtual thing, you can see what the electric field is like right there, that sort of thing.
So the original specification that I was saying does not include compartment model.
But I think it would be good to
It'd be
have,
nice to
because-
add to it, but I think you.
Because I think it's close to what most people are working on. It's close to biology. It's I think you get geometry very nicely there. But you can also do something devious here. Instead of saying an artificial input into this, you might say, okay, you can't actually use real. Sorry, you need to use sigmoid or neurons or stuff like that. And many people grow and say, oh, I don't like it. Yeah, but that's the input you do. At least in version 1.6.
Alright, we really good at this. We spent other projects together.